Hi guys, today we are going to solve some of your KVPY S6 calculus practice problems. So calculus means your integration and limits and such things. Okay, so let me start to solve guys. The first question is integral of x square minus 1 divided by x square plus 1 into 1 by root of 1 plus x power 4 from 1 to root 2 plus 1. This is the integral and the upper limit is root 2 plus 1 because it's not clearly visible now, so it is root 2 plus 1. So guys, it is a tough question. It's a tough question because it is KVPY S6 now. So of course it will be tough. So basically why this question is tough is you need a insane substitution for this question. You need a insane substitution. That means the substitution that I'm going to do for this question is gonna mind blow you. Okay, it will be mind blowing. So what I'm gonna do, listen carefully guys. First, I'm going to divide your x square on both numerator and denominator. I'm going to divide your x square on both the numerator and denominator. When you divide your x square on the numerator, what you will get is, listen carefully guys. I can write the same integral as 1 to root 2 plus 1 only. Then when you divide your x square on the numerator, what you will get is 1 minus 1 by x square. Correct now? This is what you will get when you divide your x square on the numerator. Because guys, when you divide your x square on the numerator, I will get it as x square minus 1 divided by x square. X square minus 1 divided by x square nothing but 1 minus 1 by x square. This is what you will get in the numerator when you divide x square. Now, in the denominator what we are having? X square plus 1 into root of 1 plus x power 4 is a denominator. Now, if I am going to divide your x square on this particular denominator, what denominator are we having now? We are having x square plus 1 into root of 1 plus x power 4. X power 4, right? Yes. 1 plus x power 4. This is the denominator that we are having in the integral. So if I divide your x square on this denominator, what I am gonna do is, listen carefully guys. Now I am going to split this x square. I am going to split this x square as x into x. Can't I do that? Tell me one thing. When I divide this denominator by x square, I can split it as x into x. Correct now? X into x. Now after splitting, try to do one thing. Divide your x square plus 1 divided by x and do your root of 1 plus x power 4 divided by x. That is what you are supposed to do. Such a easy thing, na? That is what you are supposed to do. By dividing the x square on this particular denominator value, that is x square plus 1 into root of 1 plus x power 4, split your x square as x into x so that you can do x square plus 1 divided by x. That is nothing but what? X square plus 1 divided by x is what? That is x plus 1 by x. Correct now? This is what you will get when you divide x square plus 1 by x. Now, if you need to do root of 1 plus x power 4 divided by x. Root of 1 plus x power 4 divided by x is what? That is nothing but root of 1 plus x power 4 divided by x will be root of, what you are supposed to do is very simple thing guys. You can write it as root of 1 plus x power 4 divided by x as divided by root of x square. Correct na? You can write like this na. So if I can write like this, the same roots can be written as root of 1 plus x power 4 divided by x square. So from this I would say that this root is nothing but 1 by x square is what? 1 by x square only. So x power 4 divided by x square is x square. Then plus of 1 by x square. That's all. Can't I write like this? Can't I write your denominator as this particular form when you divide your x square? So when I divide by x square, this is what you will get, because x square plus 1 divided by x is nothing but your x plus 1 by x, and root of 1 plus x power 4 divided by x is nothing but root of x square plus 1 by x square. How? It's very simple, guys. Root of 1 plus x power 4 divided by x can be written as root of x square, because our x and root of x square is same now. So from this, you know root a by root is nothing but root of a by b, and that is how it is root of 1 plus x power 4 by x square, that is equal to x square root of x square plus 1 by x square. Very simple. Very simple. Just divide your x square on both numerator and denominator, then put dx. Now after this, what you need to do is use your substitution method. What you need to do? Use your substitution method. So using a substitution method, what I'm going to do is, I'm going to take your, what I can substitute, think, I can take your x plus 1 by x as t. When you take your x plus 1 by x as t, then 1 minus 1 by x square, 1 minus 1 by x square of dx will be equal to dt, correct now? Will be equal to dt. When you take your x plus 1 by x as t, then 1 minus 1 by x square of dx will be equal to dt, because we know that your dt is nothing but the differentiation of t's value. The differentiation of x plus 1 by x is what? So derivative of x is 1, derivative of 1 by x is minus 1 by x square of dx, and that will give us dt. This is the substitution I am taking now. When you use this substitution, this integral can be written as, guys listen, in the numerator we are having 1 minus 1 by x square of dx. 1 minus 1 by x square of dx is nothing but dt. 1 minus 1 by x square of dx is nothing but your dt. So I can write it as dt. Then divided by x plus 1 by x. X plus 1 by x is your t. X plus 1 by x is your t. Into next what we are having. Try to understand, guys. Next what we are having. Next we are having x square, root of x square plus 1 by x square. Now I can write this as root of I can write this x square plus 1 by x square as t square minus 2. T square minus 2. I can write like this now. I can write your root of x square plus 1 by x square as root of t square minus 2, because just try to solve it. Because guys, when you do t square, I will get x plus 1 by x whole square. X plus 1 by x whole square minus 2 only will give us x square plus 1 by x square. That is why I am saying, and that is why I said it's an insane substitution and it's a beautiful question. It's a beautiful question. So I can write this x square plus 1 by x square as t square minus 2, because the t is x plus 1 by x. So x plus 1 by x whole square minus 2 only will give us this x square plus 1 by x square. So it's a very good question. Okay. Now what will be your limits? Will the limits be same as 1 to root 2 plus 1? Will the limits be same as 1 to root 2 plus 1? Of course not, guys. I am using a substitution. If I use your substitution, then of course your limits will change according to the substitution that you are doing. How will your limit change? If I am using substitution, we know that your limits will change. How it will change here? It's very simple. In the lower limit you are having 1, right? If I am having 1 in the lower limit, your 1 acts as x. Your 1 acts as x. Then what will be t's value? If 1 acts as x, then your t's value will be 1 plus 1 by 1. Because your 1 takes the value of x now. If you consider the lower limit, then your x takes the value of 1. If your x takes the value of 1, this will be 1 plus 1 by x. 1 plus 1 by 1. 1 plus 1 by 1 is 1 plus 1. What is 1 plus 1? 2. So 2 is your t value. So your lower limit will be 2. This is how your limit change. Now when you consider the upper limit, how it will change is your x acts as root 2 plus 1. Your x acts as root 2 plus 1. That means your x takes the value of root 2 plus 1. When your x takes the value of root 2 plus 1, your t will be nothing but root 2 plus 1 plus of 1 by root 2 plus 1. Root 2 plus 1 plus of 1 by root 2 plus 1 is nothing but 2 root 2. 2 root 2. This is how the limit change. Okay guys, it's a very important part, so never ever forget that. This is your limit change. Just in your consider the lower limit, your x takes a value of 1, then your t will be 2. Now when you consider the upper limit, your x takes the value of root 2 plus 1, then your t will be 2 root 2. Just solve this x plus 1 by x. So your limits will take the value of t, because t substitution only I am doing now. That's all. Now I will rub this because this is not needed now. So after this, what you can do is very simple. After this, it's gonna be an easy task. Now I'm going to write this 2 as root 2 square. I'm going to write this 2 as root 2 square. You know the reason, na? You know what is the reason I'm writing this 2 as root 2 square? Of course, it's an easy one. So you know when standard integral, na? Integral of dx divided by x into root of x square minus a square will be equal to 1 by a of secant inverse of x by a plus some constant. But for definite integral, you don't need to put plus some constant. Okay, this is a definite integral, so I don't need to put this plus concept, plus constant. So now this standard integral and this integral are same now. This standard integral and this integral are same, because in this integral also I am having x, that is your t, into root of x square minus a square, that is root of t square minus root 2 square. Correct now? Your a is nothing but a constant, so here also we are having constant, that is root 2, and x is nothing but a variable, that is your t here. So in this integral, your t is x, your t is x and your root 2 is a. Now using this particular formula, I can write the same integral as 1 by a. 1 by a is what? 1 by a is nothing but 1 by root 2, because your a is root 2. Correct now? So I can write the same integrals 1 by root 2. Then into secant inverse of x by a. Secant inverse of x by something but x by a. X by a is what? T by root 2. X by a is what? T by root 2. Why? It's root 2, no, sorry. It's root 2. T by root 2, because we are having 1 by of secant inverse of x by a. 1 by a is 1 by root 2, because a is root 2. Then secant inverse of x by a. What is your x? There is t. So secant inverse of t by root 2. Then the limits are from 2 to 2 root 2. Correct now? The limits are from 2 to 2 root 2. Now from now you are supposed to solve this limits. You know how to solve the limits now. First put 2 root 2 in place of t. Next put 2 in place of t. That's how you solve. I just use this standard integral. Because guys, 1 by a is 1 by root 2. Then secant inverse of x by a is t by root 2. Because your a is root 2 and your t is x. Because always we know that your a is a constant, x is a variable. Please remember that. Now I just need to solve this limits. Okay. So limit solving, of course you people know that. So just first put 2 root 2 in place of t. When I put, I will write this same expression as, when I put 2 root 2 in place of t, I will write it as 2 root 2 divided by 2. Then minus of 1 by root 2 into secant inverse of t by root 2. Now put 2 in place of t. Then I will get 2 by root 2. This is how we solve the limits. Now it's very simple guys. Just first put 2 root 2 in place of t. Then you will get 1 by root 2. Here I should put 1 by root 2. Na? So you will get 1 by root 2 into secant inverse of 2 root 2 by 2 root 2. Here also root 2. Okay. So you will get it as 1 by root 2 into secant inverse of 2 root 2 by root 2. Because when I put 2 root 2 in place of t, this is what you will get. After minus of, then put 2 in place of t. This is what you will get when you put 2 in place of t. After this root 2 will get cancelled. So I will write the same expression 1 by root 2 into secant inverse of 2, then minus of 1 by root 2 into secant inverse of root 2 by root 2. 2 by root 2 is what? Root 2 only. Factorization. After this very simple task, take it 1 by root 2 common. I will get it as Secant of 2 minus secant of root 2. What is secant of 2? Pi by 3. What is secant of root 2? Pi by 4. So the answer will be this. So pi by 3 minus pi by 4 is what? Pi by 12. So 1 by root 2 into pi by 12. So that is equal to what? That is equal to pi by 12 root 2. 12 root 2, and that's the answer for this question. That's the answer for the question. So answer is pi by 12 root 2. What a beautiful question, guys. See, KVPY is this level. In advance, not even in advance, you use this much techniques. That's why I said it's an instant substitution, because basically, try to understand, guys. Mostly, not in every question we use this particular standard integral, that is integral of dx by x into root of x square minus a square. Basically, many people only try to remember that 4 standard integrals like your integral of dx by a square plus a square, integral of dx divided by x square minus root of x square minus a square. You people mostly remember those formulas only, because those formulas are most expected in your J advance. But in this KVPY, of course, they can ask any standard integral. Okay, so you should be pakka in all the standard integral, and that is what KVPY proves to you. Okay, so pi by 12 root is the answer for this question. You just need to solve this, your limit solving. You know that now, and that's all. I found the answer is pi by 12 root 2. Let us move on to the next question. Our next question is limit of x tends to 0 of integral of t sin 10t of dt from 0 to x divided by x. So guys, when you solve this limit, that means when you put your x as 0, of course you will get the form as 0 by 0. Correct now? When you put the x as 0, you will get it as 0 by 0 form, because guys, in the numerator, when you put the x as 0, in the integral, your upper limit will be 0 now. If your upper limit is 0, then of course the whole integral will be 0, because your lower limit is also 0. Now, when you put x as 0 in the denominator, it will be, of course, it will be 0. So 0 by 0 is the form that you will get when you solve this limit. That means when you put the x as 0. So as I am getting 0 by 0, what can I do now? If I get 0 by 0, which is an indeterminate form, what can I do now is, I can use your Lopital rule, a famous thing now, Lopital or L'Hospital. Lopital rule, okay. So Lopital is the famous one, of course everybody knows that. Because guys, in most of the limits question, Lopital rule, pakka you will use, I know, okay. If you get 0 by 0 or infinity by infinity, indeterminate form, okay. So these two forms only you should use. For 0 by 0 and infinity by infinity only, you can use Lopital rule. So as I am getting 0 by 0, I can use your Lopital rule. What your Lopital rule says is, differentiate your numerator and differentiate your denominator. Differentiate your numerator and differentiate the denominator. Now, the thing is, when I differentiate like that, what you will get is, limit of x tends to 0, when you differentiate the numerator, we will get it as d by dx of integral of t sine of 10t of dt from 0 to x. Then if you differentiate the denominator, d by dx of x. Now, the thing is, you can differentiate the denominator very easily, because d by dx of x is 1. D by dx of x is 1, so nothing problem in that, and that is not a big deal. But in the numerator, you are supposed to differentiate a definite integral. You are supposed to differentiate a definite integral. That is a difficult part now. It's a difficult part. That is a difficult part for the people who don't know Newton-Leibniz formula. But it's an easy part for the people who know Newton-Leibniz formula. I'm saying an easy dialogue now. So differentiating the denominator is not at all a problem. So d by dx of x is what? That is 1. So directly I will write this as 1 because it's very easy. So d by dx of x is 1. Now I need to differentiate your numerator. That is what the problem now. So if in order to differentiate the definite integral, what will you use? Newton-Leibniz formula. Newton-Leibniz formula is what you use in order to differentiate a definite integral. So what your Newton-Leibniz formula states is d by dx of integral of f of t dt from ux to vx can be written as f of v of x into derivative of v of x minus f of u of x into derivative of u of x. This is what your Newton-Leibniz formula states. If you want to differentiate a definite integral where integral f of t of dt related by from ux to vx, that definite integral, that differentiation can be written as f of v of x, that is f of upper limit into derivative of upper limit minus f of lower limit into derivative of lower limit. This is what your Newton-Leibniz formula states, and that is something I am going to apply in this particular limit. So what you can do is, as we are having divided by 1, anyway it will be same value, because divided by 1 means any number divided by 1 is that number, so I don't need to write that. Now using a Newton-Leibniz formula, I can write the same as limit of x tends to 0 of d by dx of integral of t sin 10t of dt from 0 to x. Now here your u of x is 0, your v of x is x, and your f of t is t sin 10t. Correct now? That is the f of t. Now if we need to differentiate, you need to do f of v of x, that is f of upper limit. F of upper limit means f of x. F of x. In order to find the value of f of x, just put your t as x. Just put your t as x. When you put your t as x, I will get this as x into sin 10x into your derivative of upper limit. Derivative of x is 1. Then minus of f of lower limit, that is f of 0. F of 0, just put your t as 0. When you put your t as 0, I will create as t into sin 10 into 0, because when I put your t as 0, it will get as 10 into 0, 10 into 0 is 0 only. Then into your derivative of lower limit, that is derivative of 0, that is 0 only. So 0 into sin 0 into 0, of course it will be 0, so I don't need to write this. Now after this, it's a very simple task. X sin 10x into 1, so x sin 10x into 1 is x sin 10x. So now you are supposed to solve this limit. So limit of x into 0 of x sin 10x. How will you solve this? Just put x as 0. You know how to solve limits. Now just put your x as 0. So you put your x as 0. Directly answer is 0 for the question. Answer itself is 0. Answer itself is 0. So think this Newton-Leibniz formula. d by dx of integral f of d dt from ux to vx as f of v of x into derivative of v of x minus f of v of x and derivative of u of x. That's all. Very simple. That's all guys. The answer is 0. Let us move on to the next question. Our next question is integral of cos square x divided by 1 plus a power x of dx from minus pi to pi. So guys, at the first sight itself, that means at the first instant when you see this question, you may say that we are gonna use King's rule. Absolutely, we are gonna use King's rule only. So that exposure is what is needed. Okay. At the first sight itself, you should say that I am going to use King's rule. At the first sight itself, I am going to use Newton-Leibniz formula. At the first sight itself, I am going to use your Wallis theorem. At the first sight itself, I am going to use your what? That integral. That means limit as sum of integral. Okay. So, like that, you need to know everything. That is what you mean by exposure. Okay. If you are pakka in concept and if you have solved every problems, then of course you will say that. Okay, that is what is very very important. Wallis theorem means you know now Wallis theorem, a big formula. Okay, so but here only I am going to use King's rule only. So King's rule. So what your King's rule says, it's very simple. Integral of f of x of dx from a to b can be written as integral of f of a plus b minus x of dx from a to b. This is what our King's rule said, and that is something I am going to apply in this integral. Guys, I have said this King's rule thousands of times. Okay, so integral f of x of dx from a to b can be written as integral of f of a plus b minus x of dx from a to b. This is what our King's rule says, and that is something I am going to apply this integral. Okay. So now what I want to do is, when you use a King's rule, you will get it as integral of f of a plus b minus x. A plus b minus x is lower limit plus upper limit minus x. That is minus pi plus pi minus x. F of minus pi plus pi minus x is f of 0 minus x is f of 0 minus x, because minus pi plus pi is 0. So f of 0 minus x is f of minus x. Just try to find the value of f of minus x. That is what you are supposed to do now. If you want to find the value of f of minus x, what you need to do is just put your x as minus x in the integral. Put your x as minus x in the integral. So when I put like that, I'll get the same integral as, when you put your x as minus x in the cos square x, I'll get it as cos square of minus x then divided by 1 plus a power minus x of dx. Then the limits will be same only. Okay, the limits will be same, that is minus pi to pi, because in the King's rule also the limits is same, that is a to b. So that's why the limits will be same as minus pi to pi. So this is what you will get when you use your King's rule, because we are supposed to find the value of f of minus x. F of minus x means put x as minus x. Now cos square of minus x, guys, cos square of minus x is cos square of x only, because we know that cos of minus theta is always cos theta when your theta lies in a certain angles. Okay, acute angles, you can say it as acute angle. Okay, so your cos of minus theta is always theta when theta is an acute angle. Okay, that's what I'm saying. So cos square of minus x will be always cos square x. So I can write this cos square of minus x as cos square x. Cos square x. Now after this, this is what the integral that we got. So let me write this integral as IA. Let me take this integral as I. In the question I gave an integral, that integral I am taking as I. This will also be I, because both this integral are same. Both the integrals are same, and that is something a King's rule states, right? Integral f of x dx from a to b, and this integral are same. So this integral f of x dx is only this I. Integral of f of a plus b minus x of dx only this I. Now the next step that I am going to do is, now listen carefully guys, why we are using King's rule? The reason we are using King's rule is in order to make your integral easier. Even though I use King's rule, now also the integral looks complicated. Now it's not very easy now. Now also it's very complicated. If you use King's rule, and even though it is very complicated, means what you can do is try to add those two i's. Try to add these two i's. This I and this I. Add these two integrals. When I add I plus I is 2ia. So 2i, now add these two integrals, because as the limits are same, we can directly add. So integral minus pi to pi only. When you add the inside values, I get this cos square of x divided by 1 plus a power x, and if you need to add this integral, cos square of x divided by 1 plus a power minus x. That is what you will get when you add these two i's. Just I'm trying to add these two i's. I plus I is 2i. As the limits are same, you can add it directly at the inside values. That is cos square of x divided by 1 plus a power x plus cos square of x divided by 1 plus a power minus x. Now what I'm going to do is, in this particular expression, right, I'm having 1 plus a power minus x. I can write this a power minus x as 1 by a power x. That's the laws of exponents, correct now? I can write a power minus x as 1 by a power x. That's the laws of exponents, a basic concept. That is what I am doing now. Now after this, very simple guys, 1 plus 1 by a power x, that you are supposed to solve this. So 1 plus 1 by a power x, how will you solve? LCM. 1 plus 1 by a power x, LCM. So when you see LCM, I can write it as a power x plus 1 divided by a power x. Now after this, you can take this divided by a power x to the numerator. When you take I will get it as cos square of x into a power x. Correct now? Just I took LCM. Simple task. Very, very simple task. That's what I did now. So what I did is, I had 1 plus a power minus x. So 1 plus a power minus x, I can write that a power minus x is 1 by a power x. 1 plus 1 by a power x is a power x plus 1 divided by a power x. Just to do this divided by a power x to the numerator, we can take like that now. Because if we divide, in here going to take with the numerator, and that is something I did earlier. Okay? It's a very simple task. Now, what I'm going to do is, listen carefully guys. Now I am supposed to add these two expressions. So when I need to add, I will get this 2i as 2i is equal to integral minus 5 to pi. Now take your cos square x common. When you take your cos square x common, I will get it as 1 plus a power x divided by 1 plus a power x. Correct now? This is what you will get when you take your cos square x common. Correct na? This is what you will get. This is what you will get when you take cos square x common. So when you take cos square x common, I will get it as 1 plus a power x, it will be 1 plus a power x. Because listen carefully, when you take cos square x common, you will get it as cos square x into 1 by 1 plus a power x plus of a power x to by a power x plus 1. As a power x plus 1 and 1 plus a power x are same, so denominator is same, you can directly add the numerator, and that's so 1 plus a power x to by 1 plus a power x. So this is what you will get when you take your cos square x common. I will cancel these two expressions. So now it's a very simple task. It's a very simple integral. It's a very simple integral. That's what you people think now. But now also it's not very simple. You need to do some things and then only it will be very simple. Okay. So what you need to do is, now what you can do is, this is what the integral I am having. So 1 plus a power x, 1 plus a power x get cancelled. So I can erase these things. Now what you need to do, listen carefully guys. In this integral, try to multiply by 2 and divide by 2. Try to multiply this integral by 2 and divide it by 2. That's what I'm going to do now. So when you multiply by 2 in this integral, and I'm going to divide it by 2 into integral of cos square x for minus pi by 2. Minus pi to pi. Now as I'm having 2, right? I'm multiplying it 2, right? I can take this 2 inside. So 2 cos square x, this will be 1 by 2. Just a basic thing guys. Just I multiply your 2 in this integral and divided this integral by 2. That's a basic thing and a basic concept that you people know already. So when I multiply this integral by 2, I'll get it as integral of 2 cos square x divided by minus 5 to pi, and also I need to divide it by 2. That is also there na? Do you guys forget that? So that's what I did now. Now after this it's gonna be very easy. So I can write this 2i as 1 by 2 into integral of 2 cos square x. I can write this 2 cos square x as 1 plus cos 2x from minus pi to pi. So 1 by 2 into integral of 1 plus cos 2x from minus pi to pi. Because 2 cos square x and 1 plus cos 2x are same. How? You should only know. So we know now cos 2x is nothing but a double angle formula. Cos 2x is nothing but cos square x minus sin square x. So 1 plus cos square x minus sin square x. How will you solve that? 1 plus cos square x minus sin square x. How will you solve this? 1 is what? Sin square plus cos square is Pythagorean identity. So sin square x plus cos square x. Then plus of cos square x minus sin square x. Your sin square x will get cancel. You will get cos square x plus cos square x. There is 2 cos square x. And that's how we are getting like this. So I'm just writing 2 cos square x as 1 plus cos 2x. Anyway, it will be same just by using a double angle formula. Cos 2x is cos square x minus sin square x. Now, after this, I will erase this. So 2i is equal to this integral. 2i is equal to this integral. After this, you need to integrate guys. It's very simple task now. So 2i is equal to, I will take this 2 to this side, okay? And take this 2 to that side, I will get it as I is equal to 1 by 4. I am just taking this 2 to that side, 1 by 4 into integral of 1 plus cos 2x. Integral of 1 is what? X. Integral of cos 2x is what? Sin 2x by 2. You should know these things already. I can't explain, okay? So integral of 1 is x, integral of cos 2x is sin 2x by 2. Then the limits are from minus 5 to pi. The limit solving method. That's all. Just the integral of 1 is x, integral of cos 2x is sin 2x by 2. Now I'll put the limits minus 5 to pi. You're supposed to solve this limit. So I is equal to 1 by 4 into. First to put x as pi. When you put it x as pi, I will get it as pi plus sin 2x by 2. When I put it x as pi, I will get as sin 2 by 2. Sin 2 pi by 2. Sin 2 pi by 2 is what? 0. Sin 2 pi by 2 is 0. Then minus of, when you put minus pi in place of x, I will get it as minus pi plus of sin of 2x by 2. When you put it x as minus pi, I will get it as sin of minus 2 pi by 2. Sin of minus 2 pi by 2 is also 0. Correct na guys? When you put in minus pi in place of x, I will get it as minus pi plus of sin of minus 2 pi by 2. Sin of minus 2 pi by 2 is 0 only. So I will get it as I is equal to 1 by 4 into, when you solve this, that is 2 pi a. So 1 by 4 into 2 pi is what? Pi by 2. And that's the answer for the question. This is also a beautiful question. I is equal to pi by 2 and that's the answer for the question. This is also a very good question guys. Okay, KVPY, every questions are like, every questions are next level na? Next level. So that means every questions are very good. So the answer is pi by 2. The thing is King's rule after the substitution, not substitution, some other parts, then like that we are keep going and that's how you should solve, and some trigonometric formula. So 1 plus cos 2x is what? 2 cos square x. Okay, that you also need to remember. So that's all guys. Let us move on to the next question. Our next question is limit of x tends to 1 by root 2 of x minus cos of sines of x to be 1 minus tan of sines of x. And guys, it's a good conceptual question, and you know integration na? In integration we do substitution, right? Like that in limits also I am going to substitution. See in what way they are asking in KVPY. Brilliant na guys. In integration only use substitution, but in limits also we are going to use substitution. It's such a good thing. Okay, so what I'm going to do is I'm going to take your sine inverse of x as theta. I'm going to take this particular term sines of x as theta. Then if sines of x is equal to theta, then your x will be nothing but sine theta. Correct na? If I take your sines of x as theta, then your x will be sine theta. Obvious thing. Trigonometry to inverse trigonometry to trigonometry conversion. That is what. If your sines of x is equal to theta, then x will be sine theta. So I am taking your sines of x as theta, then x will be sine theta. So what will happen is, listen carefully, I can write the same limit as, guys now you should listen very carefully. So I will get it as, what is your x? Your x is nothing but sine theta. Because if sine of x is equal to theta, then a theta will be sine theta. So I am having x, so sine theta. Then minus of cos into sines of x. Sines of x is something with theta. Now only I took no. Then divided by 1 minus tan of sines of x. What is sines of x? Theta. Now what the limit tends to? This is where you guys should be very careful. You should not write x tends to 1 by root 2 now. This is where most people will do mistake. If I do like this, you should not write like x tends to 1 by root 2. That's a mistake guys. Never ever do that. You should not write it as x tends to 1 by root 2. But I can write it as theta tends to pi by 4. How am I doing this? I should not write it as x tends to 1 by root 2, but how I can write as theta tends to pi by 4? You should ask me that. So basically guys, try to understand. If I put your sines of x as theta, now this is how the term change because the x is equal to sin theta. This is how the particular expression changes. Now actually in this particular expression we are having theta, right? We are not having x. If you have x, you can write it as x tends to 1 by root 2. But of course here I am not having x. I am having the expression in terms of theta. If I have in terms of theta, then of course your theta only should tend to something. Your x should not tend to something. Basic common sense. Okay, va? As in this expression, I am not having x. So you should not put x tends to something. You should put theta tends to something. In this expression, I am only having theta, not x. This expression is in terms of theta. That's why I am saying like that. But you may ask, how will theta tends to pi by 2, man? Sorry, pi by 4. How will theta tends to pi by 4, man? Explain us. Like that you will ask. Basically, try to understand, in this limit, we are having x tends to 1 by root 2. If x tends to 1 by root 2, then theta tends to pi by 4. Because we know that your x is equal to sin theta. Correct, na? If x is equal to sin theta, that means your 1 by root 2 is equal to sin of theta. So, when you will get 1 by root 2, that's only possible your theta is pi by 4. And that's why I am saying your theta should tend to pi by 4. Mind blowing concept, na? So, theta should tend to pi by 4. This is what is very important. Okay, just by using this particular thing. As sines of x, and you put it as theta, then your x will be sin theta. If x is equal to sin theta, we know your x tends to pi by 2. So, x tends to 1 by root 2. Not pi by 2 guys, 1 by root 2. That will be equal to sin of theta. When you will get 1 by root 2, that's only possible your theta is pi by 4. If theta tends to pi by 4 only, your x tends to 1 by root 2. And that's why I am writing your theta tends to pi by 4. Now, after this, what you need to do is limit of theta tends to pi by 4 of sin theta minus cos theta divided by 1 minus tan theta. Now I am going to write this tan theta as sin theta by cos theta. I can write like that basic relationship. We know now guys, tan theta is sin theta by cos theta. Now after this, try to take LCM in the denominator. When you take 1 minus sin theta by cos theta, will be nothing but cos theta minus sin theta divided by cos theta. This is what you will get when you simplify that 1 minus tan theta. Just I took your tan theta as sin theta by cos theta. Then I took LCM. After this is what you will get in the denominator. That is cos theta minus sin theta by cos theta. Now I will take this cos theta to the numerator because if you have division, you should reciprocate it. So denominator will become ulta. It goes to numerator. You know now guys, if we divide, of course you will take to the numerator. As we are having divided by cos theta, I took it in the numerator. That's all. Simple concept. Simple concept. I shouldn't explain these things. Now, sin theta minus cos theta by cos theta minus sin theta is what? That is minus 1. How? It's very simple. I can write this cos theta minus sin theta as minus 1 into sin theta minus cos theta. Correct now? I can write that cos theta minus sin theta as minus 1 into sin theta minus cos theta. Anyway, we'll be getting cos theta minus sin theta. So this term will get cancelled guys. These are all basic things, factorization. So that's why I'm saying 1 by minus 1 is minus 1 only. So limit of theta tends to pi by 4 of minus 1 is left out. So minus 1 into cos theta is minus cos theta. Minus 1 into cos theta is minus cos theta. After this, it's very simple. When you put as your theta tends to pi by 4, just put your theta as pi by 4. What is cos of pi by 4? What is cos of pi by 4? That is 1 by root 2. As your cos of pi by 4 1 by root 2. This will be minus 1 by root 2. And that's the answer for this question. It's a very good conceptual question. The very good conceptual question. Just for theta as pi by 4. When you put theta as pi by 4, you will get minus of cos of pi by 4. Minus of cos of pi by 4 is minus of 1 by root 2. And that's the answer for the question. The thing is this particular one. And also if x tends to 1 by root 2, your theta tends to pi by 4. That concept is also very important. That's all guys. Let us move on to the next question. Our next question is integral of cos x minus sin x divided by root of 8 minus sin 2x of dx is equal to sin inverse of sin x plus cos x divided by b plus some constant, and they are asking the value of b. So guys, what I'm going to do is focus on this integral. Try to focus on this integral. In the denominator, I'm having a square root, right? Inside square root, I'm having sin 2x. I'm going to solve the sin 2x separately. Sin 2x. Now, what is sin 2x? Double angle formula. So, sin 2x is something but 2 sin x cos x. Your double angle formula guys, because sin theta is equal to 2 sin theta cos theta. Using your double angle formula, I wrote your sin 2x as 2 sin x cos x. I wrote your sin 2x as 2 sin x cos x. Now, after this, what I'm going to do is, in this particular term, I'm going to add 1 and subtract 1. In this particular term, I'm going to add 1 and subtract 1. Why I'm going to do that? Why I did that? Anyway, no changes is going to happen because plus 1 minus 1 no changes. But why I did that big? Why I did that? Because I can write that 1 as sin 2x is equal to, I can write that 1 as sin square x plus cos square x, Pythagorean identity, then plus of 2 sin x cos x minus 1. Can't I write like this? Can't I write like this? Plus of can't I write like this? I just wrote your 1 as sin square plus cos square x, Pythagorean identity, because sin square plus cos square is equal to 1. So sin square x plus cos square x plus 2 sin x cos x minus 1, because this minus 1 is left out. So now what is this sin square x plus cos square plus 2 sin x cos x? A square plus b square plus 2ab. A square plus b square plus 2ab is nothing but a plus b whole square. That is sin square x plus, not sin square x, sin x plus cos x whole square. Correct now? I can write like that. So sin square x plus cos square x plus 2 sin x cos x is sin x plus cos x whole square, a plus b whole square formula, because it is a square plus b square plus 2ab, that is a plus b whole square, that is sin x plus cos x whole square, then minus 1. Okay. Now after this, what you are going to do is, in this integral, put the value of sin 2x as sin x plus cos x whole square minus 1. When I do like that, I will get the same integral as cos x minus sin x divided by root of 8 minus of sin x plus cos x whole square, then minus 1. I can write like this now. Think carefully and say. Just I replaced your sin 2x as sin x plus cos x whole square minus 1, because just now we evaluated your sin 2x as sin x plus cos x whole square minus 1. Just I wrote like that. Now after this, substitution, okay. So what I'm going to do is, what substitution I can take is, I'm going to take sin x plus cos x as t. Then your dt will be nothing but cos x minus sin x of dx will be equal to your dt. Correct na? Correct na? If your sin x plus cos x equal to t, then cos x minus sin x of dx will be your dt, basic thing. Because sin x plus cos x thing means the dt will be differentiation of t value. So differentiation of sin x cos x, differentiation of cos x is minus sin x of dx will be your dt. Now when you use a substitution, here I should put dx, right? Yeah, dx. I forgot to put dx, that's all. Now using a substitution, in the numerator I am having cos x minus sin x of dx. Cos x minus sin x of dx is dt. So integral of dt divided by root of 8 minus of sin x plus cos x square. What is sin x plus cos x? That is t. So t square minus 1. That's all. This is what you will get when you use this substitution. So in the numerator, that is cos x minus sin x of dx, that is your dt. Then in the denominator I am having root of 8 minus of sin x plus cos x whole square. Sin x plus cos x t, so t square minus 1. Now after this I will rub this. So after this I can write the same integral as integral of dt divided by root of 8 minus of t square plus 1. Because 8 minus of t square minus 1 will be nothing but 8 of minus of t square plus 1. So 8 plus 1 is what? 8 plus 1 is 9. So 9 minus t square. I can write this inside value as 9 minus t square. Very simple guys. 8 minus t square minus into minus plus. So 8 minus t square plus 1 is 9 minus t square. Okay. Now after this, just try to solve this definite integral using our standard integral. So standard integral, what formula? Integral of dx divided by root of a square minus x square is equal to 1 by, not 1 by a, sin inverse of x by a plus some constant. Sorry guys, I told 1 by a. I confused with the integral of dx divided by a square plus square. More formulas are there now. It's difficult, but yeah. Okay, so integral of dx divided by root of a square minus x square is equal to sines of x by plus some constant. Very important formula where a is a constant, x is the variable of the integral. Okay, so here your a is 9. Sorry, your a square is 9. Then your a will be 3. So you can write this 9 as 3 square. So now your a is 3a, x is ta. So I can write the same integral as sines of x by a. That is sin inverse of x. What is x? T. Because guys, these two standard integrals same. Your a is 3, your x is t. So sin inverse of t divided by a. Your a is 3. Then plus some constant. This formula is very important. Integral of dx by a square minus x divided by root of a square minus x square is equal to sines of x by plus some constant. Very important formula. Never ever forget that. So here your a square is 3 square, x square is t square. So sines of x by a will be sines of t by root 3, t by 3. Why? Because your x is t and a is 3. That's all. So I will wrap this. After this, what is value of t? What we substituted? We substituted as sin x plus cos x. So sin inverse of your t will nothing but sin x plus cos x divided by 3 plus some constant. That's what we substituted. Now what is the value of t we substituted? Sin x plus cos x, because t value is nothing but sin x plus cos x. That's all. So if it, as we substituted t as sin x plus cos x. Now this expression are the same. Because sines of sin x plus cos x same here plus some constant. So of course your b will be equal to 3 because here we are having 3. So b is equal to 3 and that's the answer for the question. It's a beautiful question. So that's all guys. I hope you guys would have enjoyed this session. So all the best guys, do your KVPY well. So this is S6 calculus question. I hope it will help you because some questions are guys, most of the questions I picked are very tough question. Most of the questions that I picked up are good questions, okay? So it will be tough only. So please follow it. So that's all guys. Thank you. Make education simple.